So a lot of what we did, in particular, I would say in the first unit, and then what we're doing in this unit, at least the first half of this unit, is again understanding the relationship between the equation, in this case of polynomial functions, so polynomial equations, polynomial functions, understanding the relationship and the patterns between the equations and the graph. So this is similar to in grade 10 when you first start learning about quadratics and you notice that the vertex is in because it's an important part of a quadratic, and I can graph given it, or maybe I can write an equation if I know the vertex, that kind of thing, right? So it's an important tie between the equation and the graph. So that's like what we're doing right now. That's what yesterday was kind of about. Yesterday we were exploring carefully, but at least the end behavior is telling me that it's cubic. And then the only other one is graph 7. So graph 7. I don't know where that came from. Graph 5. So which one is it, and how do you know? Okay. Why?
Because there's no X-Intercept.
B. And then I'm going to put the pictures back up and see if you can pick out which one it is. Okay, how are we doing? Did we figure out what the second one is? Who's got it? Alex? 4? Did anybody else get 4? Whoops. Anybody else get 4? Yeah? Nice. So why do we pick 4? Well, like there's lots of different ways of doing this, right? So this has an X-intercept at 0. At +1, it'll be a cubic twist. And at -3, it will be a turning point. So it's going to be like a quartic turning point, but are you going to be able to tell the difference between that and a quadratic turning point? Probably not. So don't worry too much about that, but it's a turning point because it's an even exponent. And some of these other ones have X-intercepts at 0 as well. Like this one has an X-intercept at 0, but it's a turning point X-intercept, and this one's a pass-through X-intercept. So we start, like what you would do, tomorrow's learning goal has an activity kind of like this, where you're like matching graphs. And you're really going to compare all of the different functions and all the different graphs together. We're not going to do all 6 of these right now. If you want to do it for practice and then check, I'll put the answers up on the classroom. You can check them after. Okay, any questions about that? Oh, and so then what else? So this is a degree 8. 4 + 3 + 1 is degree 8. And it's got a leading coefficient, so both ends are pointing up. So I start looking, and I look. This one's got both ends pointing up. But it's only got 2 X-intercepts. This one has both ends pointing up, turning point, and it does look kind of flat. Cubic twist and a pass-through. So there you go. Like now all of those things match, right? You might not need every single one of those things. Like some people think they're really smart. Like, I'm really smart. I don't even need to go through. I don't even need to figure out the X-intercepts. I'm doing something else to figure it out. Well, be careful because sometimes it's not going to work. And you also have to be able to, if I gave you an equation, I might just say, list all of these characteristics. It might not be like match it to a graph, right? So there are other kinds of questions. So in other words, you want to be able to look at the factored form of a of a polynomial function and be able to get all of that information from it, right? That's something you want to be able to do. I will take a look at D and E just quickly. I don't know that you have to write this down. What's different about D and E? They're not written out in fully factored form, okay? So I would have to simplify. So how would I simplify this one? Well, I've got a difference of squares, so that's like x plus 3 times x minus 3, right? Like you can't have it not fully factored and fully simplified. It won't work. And what is x plus 2x squared plus 6x plus 9? It's x plus 3 all squared. You could use your favorite factoring method of choice to get that, but it's a perfect square trinomial, so it should be pretty easy. And then I'm going to simplify this again and go x plus 3 cubed times x minus 3. And its leading coefficient positive. It's degree 4. It's got 2 X-intercepts. One's a cubic twist at -3 and one's a pass-through at +3. So that looks like, I'm going to say this one. Cubic twist at -3, pass through at +3, leading coefficient positive, right? Everything matches. Nice. And then E, common factor of X. These are just quick little reminders. You were supposed to do some of the plus 8x plus 16, some of the factoring practice, and there's gonna be is there a little bit of factoring today in the work? Yeah, tiny little bit. And in a few days, we're gonna be really factoring. So you gotta get your factoring skills up nice and sharp. And so then this is x times x plus 4 all squared. So this is it. There's our other cubic one. It's got a pass-through x-intercept at 0. And it's got a turning point x-intercept at -4. See again how it all matches? Okay, we're going to move on. We're not going to do the last two. Here we go. Use the given information to make a sketch of each function using factored form. So what do we notice about the first one? It's not factored, not in factored form. And we don't really know anything about almost, very little, just a little bit, but that are in like simplified form, expanded form, standard form, whatever you want to call it. We don't know much about polynomials in that form, right? Except for linear. So it's not very useful. So in grade 10, you'd either complete the square or factor it. So let's go ahead and factor it. Common factor of 3, x squared plus 2x minus 8. And simple trinomial factoring, two numbers that multiply to 8 and add to 2. X plus 4x minus 2. Happy with that? So from grade 10, we know a lot about quadratic. And this is 3, this is 1, this is -3.